Hey, financial management guys, hope you feel okay. We're almost at the end of the course. Just to let you know that I actually enjoyed teaching you a lot, very entertaining cohort. And this video is for you so that you will remember me in a positive light. Okay, so what I want to do today is to talk about project planning. So the question is the following. Let's say that you are a company, okay, and then you have two projects. You have project A and project B. Okay? Now, project A, let's say it's setting up a plant. And project B is developing some new product, maybe developing software. Okay. So in some sense, project B requires much less money to invest in project A because to build a plant, it's actually a heavy duty stuff, okay? For example, we had last month, okay, Westinghouse, okay, did not appreciate estimate, okay, what is going to be the cash flows by building these build nuclear reactors, the first one in 30 or 40 years in the US, okay, and as a result, they actually went bankrupt because they actually underestimated their cash flows, how much they want to invest. But let's assume that you do not have those kind of problems and you built it a lot of times, so you know what is going to be your cash flows for project A, and you know how much your cash flows will be for project B, and then you know that you want to invest some initial amount, okay? Now, the return of a $64,000 question is, how do I decide between project A and project B? Should I invest in project B or should I invest in project A, okay? And that's what we're going to talk about today. This is what, this is part of the capital budgeting or financial planning or whatever you guys want to call it, okay? Now, the driving force, I'm going to talk about three methods to compare. The first method is the NPV, which is the most direct and by far the best method. The second method is the IRR, internal rate of return. And the third method, okay, is the MIRR, which is basically modification of the IRR. So it's I don't remember, it's like something with internal rate of return. I think it's modified internal rate of return. Now, what is the NPV? The NPV is actually, the idea of the NPV is very, very simple. What you want to do, you want basically to value the project today. So what they say, what the NPV says, it says, okay, let's assume that the money that you want to sell this project to somebody, what is going to be the price that this guy is going to give you? Okay? So let's say the price for these cash flows, okay, with this initial investment will be $1,000. And the price for these cash flows, okay, with the initial investment will be actually, let's say, $2,000. Okay? So this guy is pricier than this guy, right? This guy is more expensive. So you would actually, what you would do, you would actually prefer to sell these cash flows to the guy and not these cash flows, right? Because this is cheaper, so you would like to go with these cash flows. All right, that's okay. So now, okay, the logic is like this. Okay, if you sell it to somebody and this guy is more expensive than this guy, okay, what you want to do, you want to actually concentrate on this guy because this will be, this is more beneficial from you in present value. If you want to sell it to somebody, you would choose this and not this. So why, so then you should choose this anyway, okay? So then the question comes, okay, how do I value those cash flows? If I know how to value those cash flows and translate them into a price or into a present value, because the price is actually the NPV, the net present value, okay? how much those cash flows worth for me now, okay? That's basically what is the price if I want to sell it to somebody else, okay? How do I value this? And what's the what all you need to do here, okay, is to come up with the discount rate. So say you know the discount rate for this project, and then you know the discount rate for this project. So then you have basically the formula, C1 divided by 1 plus Y, 1, let's say after 2 years, after 1 year, plus C2 divided by 1 plus Y, 1, square, plus blah, 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 CK divided by 1 plus Y, 1 to the power of K. Okay? You can sum this guy, as we did in class, and you will get the price of the A project. Let's say it's A0. Not A0, price A0. Same you are going to do with B. You are going to have basically C B1 divided by 1 plus Y1, Y2, plus B2 divided by 1 plus Y2 square, plus blah, 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 BK divided by 1 plus YK square to the K, right? Let's say 2 to the K, so 2 because it's the second part, okay? And you kind of know what is going to be your price here, and you're done, okay? Well, it's easy, but the question comes, what is your discount rate? And the answer that the NPV guys will tell you, you want to discount by the WACC, okay? By the weighted average cost of capital. And this is a tricky answer. Because what are these guys telling you? These guys telling you the following, okay? Suppose you want to fund this project. Suppose somebody you want to go and get a loan, okay? How can you get this loan? You can get this loan based on equity, right? Issuing more equity, right? So you can actually say, okay, I issue more equity, or I will get a bond. The mix of this will be basically the mix of your capital structure today. So if you have 80%, let's say, in equity and 20% in bond, okay, to fund this project, you will actually fund this project by issuing 80% of more equity and then actually issuing 20% bonds, okay? So if your project is $1,000, let's say here, we're having $1,000, so we are going to basically, so we have to take a loan. So 800 loan, 800 will be basically through equity, and 200 will be by issuing a new bond. Here it's 2,000. It's, let's say, 80-20. It's going to be 1,600 into your equity, and whatever, and 400 into your bond. Okay. And then what will be your discount rate? Well, for the equity, we know that this is going to be a return on equity. For the bond, it's going to be basically the return on bond or the yield, because that's the interest that you are going to pay. So then you want to say, okay, I have a market value, and then of market value of my project. So I will have basically the equity, the price of the weight of equity plus R plus WY times RY. Okay? That's it. This is exactly the WACC. Now, of course, it's coming, from this calculation, you see that there is a caveat. Let's say that you want to issue all, that you want to fund the project through just through equity. A typical example is basically high-tech companies. They never go to the debt market. They almost never go to the debt market, and this is a little mystery for us, okay? They always try to issue more equity to fund their projects. So in this case, okay, you are not going to have this, you are not going to have this component. So if, for example, your WACC is 10%, however, your equity, your equity, let's say your WACC, that you did this for the company is 10%, but you know that this company will always go through equity, okay? So then the WACC, but historically they still have some debt, but the WACC is going to be basically RE, right? So let's say it might be 10%, which is the return on equity for this company, okay? So then it's actually very easy. You just discount back and you find your price. So for example, if you have, let's say, cash flows of 50 and 100 for 2 years for project A with an investment of minus 60, okay, and your WACC is 10%, and here B, you're going to have basically an investment of minus 100, and and the price is 150 and 150, so those are your cash flows, then you are going to basically say, okay, let me compare minus 60 plus 50 divided by 1 plus 0.01 plus 100 divided by 1 plus 0.1, because it's 10%, so it's 0.10 plus 0.1 square. This is going to be your first project. The second project is going to be minus 100 plus 150 divided by 0.1 plus 100 divided by 1 plus 0.1 square. So you compare those two numbers, you kind of do the calculators or through Excel, as I showed you using the function NPV in Excel. Okay, and you're getting that here you are going to have one number, here you are going to have another number, okay, and those numbers, whoever this number is bigger, okay, you're going to get this project. So for example, let's say that this would be, I don't know, 75.3, and this one will be 80.1, you will go with this. If this one actually 80.1, then 75.3, you're going to go with the first one. Okay, so it's actually pretty straightforward. So this was for the WACC. Okay, what about the IRR? Well, IRR is a little bit trickier. What the IRR says to you, okay, what you want to do, you want to actually say that your NPV must be 0. So what you want to do, you want to find your discount rate, the internal rate of return in the IRR, and you're saying, okay, what is going to be the yield or the discount rate such that my net present value is going to be 0. So for example, if going to this example, okay, where you invest $100 and you have minus 150 minus 150, okay, what you want to do, and you invest these guys now, so what you want to do, you want to find what is your IRR, so it's 100 minus 150 divided by 1 plus y, minus 100 plus 150 divided by 1 plus y, plus 150 divided by 1 plus y square must be equal to 0. Okay? You find this y for both projects, okay, and you are going to go with the IRR. So you have IRR 1 and IRR 2, okay, and you are going to compare the IRR. So if the internal rate of return of the first project is bigger than the internal rate of return of the second project, you will go with the first project. Vice versa, if the internal rate of return of the second project is bigger than the internal rate of return of the first project, you go with the second project. Okay? So whoever has a bigger discount rate, so basically wherever you will get a bigger return, okay, that's the project you're going to select. Now, there is some problems with the IRR, which causes economists not to use it too much. And the problem with the IRR, okay, first of all, there is no point of comparing NPVs because NPVs are 0 both ways. Okay? The problem with the IRR is that it doesn't take the time horizon. It doesn't cope well with time horizon. What do I mean by that? I mean by that, for example, if you have an IRR of 50% for 3 years, okay, and you have 20% of IRR, let's say you have 10% of IRR for 5 years, the IRR criteria will tell you, okay, you need to select this guy. But the problem is that with this 10%, you will actually get 2 more cash flows every year or every quarter or whatever going from with this guy, okay? So it may be that this guy will have more juice in the buck than this guy because it has extra two more years, okay? Think about a company, okay? Think about the following extreme example. Let's say I'm giving you an investment with 5% coupon for 10 years and 15% coupon for 1 year, okay? And then you're going to say, okay, after 1 year I have, let's say, $15 as a return. After 10 years, I will more or less will have $50, okay? So my 10-year return is actually better than my 1 year return because I have more money, okay? However, you can say, oh my God, after 10 months, after 1 year, maybe I can reinvest the money, okay? So then you have more stuff to decide in 1 year what to do, because otherwise, you know, how can you say, okay, 15% is less than 15, okay? Or you know, or let's say yes, so it's 1 year 15%, and 10 years 5%, right? So I said that here you have more money because you have 15% return, more or less. Okay, with discount rate, maybe you have 40% return, but you still get more money in present value terms than here that you are going to get only 15%. So after 1 year, if you get this investment, if you pull the bait, you will get money, okay? But then what do you do with your money? You cannot reinvest it here because maybe it's not 5% anymore, but maybe 3%, okay? So the problem with the IRR is that if you look on the time horizon is not defined well because the NPV does a good job with that because the net present value compares everything to this day, and the cash flow formula takes the further cash flows into account. The IRR doesn't do it. Okay? So what happens in this case, for example, when your IRR of the first project is bigger than your IRR of the second project, okay? But now you do the net present value, and here you can see that the net present value of the first project is actually less than the net present value of the second project. What are you going to go with? You're going to go with this guy. The net present value will always win the IRR. That's the idea of the economics. Now, another thing that the IRR doesn't take into account, okay, is your financing rate. Because if you finance today, you will have one rate, okay? But if you finance in the future, you have another rate. Now, in the IRR case, let's say that you have a negative cash flows now, then you have some positive cash flow, and then suddenly you have more negative cash flow because you want to expand the expansions of the project, so you want to expand. So the interest rate here and the interest rate here are not the same, and for sure it's not the same as the interest rate here. So but then the IRR basically gives everybody equal weight, equal discount. So if you borrow money and you have money like this, you will get the same rate, okay? Which is not good because every time you borrow money, you can actually pay more than not borrowing money. So for that, what we have the MIRR, the modified internal rate of return of IRR, which actually copes with these two problems, okay, with the financing and with the maturity. And then it says the following. Let's say that I have cash flows. Let's say that my project is going to finish in 5 years, okay, and then I have minus 100 here today. Then I have 200. Then I have 400, and then I have then I have to borrow another $100, and here I have another $200 in cash flow, right? So 5 years. So the modified internal rate of return says, okay, let me do this. Let me first push all the cash flows, all the negative cash flows to the present. So I will, in some sense, find the net present value, okay, of borrowing money. Because I'm going to invest everything today. And let me now take those guys and push them forward. Push them forward with some known rate. Maybe it will be a WACC or some other rate that you guys kind of know. Okay? That's where the weakness of the modified internal rate of return lies, because you kind of need to know what is going to be your rate as well of pushing forward. So you push forward for the 5 year. Okay? So maybe your financing rate is going to be 10%, and then your 5-year rate is going to be 5%. Okay, then you will take this 200, and in order to push it forward, you will say, okay, it's 200 times 1 plus 0.05 to the power of 3, because I have another 3 years. So I have 200 on my second year, let's say, or the first year, whatever. Let's say it's a first year, so it's 4. Okay, not 3, but 4. Sorry about that. Okay, so I have 4 more years, so I will take $200 in terms of of a year from now. When I will push it to the 5 year, it's going to be 200 times 1 plus 0, 0.5 to the 4. But here, for example, if I have minus 100 and I have 0.10%, so when I will discount back, it's going to be minus 100% divided by 1 plus 0.1 to the power of 4. Okay? So then I'm going to have two numbers. The first number is going to be financing, and the second number is going to be return. This financing occurs now. Return will occur in 5 years. And then what the modified internal return rate return says, okay, let me find out how much money, okay, I'm going to make, what will be my yield here. So let's say when you're finding this yield, and this yield is actually very easy to find, all you need to do is to take the nth root of the future value divided by the present value, and then you subtract 1. Okay? This is going to be your modified internal rate of return. Where n, let's say if it's 5 years, then it's 5 years. Okay? You are going then to have 2 projects and compare the modified internal rate of return. And whoever modified internal rate of return is higher, you will go with this project. Once again, there can be conflicts with the NPV, and then you will always go with the NPV. But at the very least here, okay, you're taking care of the maturity problem because you're pushing all the cash flows to forward, let's say to 5 years or to 10 years, and you're hoping, okay, then in this case, you are actually going to get a better result. But once again, you can have a result where you have 1 year. In 1 year, you have a modified internal rate of return of the IRR higher than in 10 years, and then you say, okay, I will actually invest in the first year in the modified internal return of a short-term project because it's higher, okay? But then you'll have to think about, okay, what will I'm going to do with my next step, because it's going to be the same problem, okay? The NPV will say, okay, maybe you should invest in the second project because you want to prefer the cash flows to be steady and you know them, okay? Now, there are a couple of issues with all the times that you need to keep in mind. First of all, the discount rate was a WACC, and I showed you in class that the WACC is actually sometimes a moving target because it depends on the window of a historical time series that you're taking in order to calculate it. It can also depend on the window of your debt and equity. Okay, which one would you use? Would you use a market value? Some people use a book value, and they have perfect justification for that. Okay, some people can actually say, okay, this is all nonsense, and we already did this project 10 times, so we know exactly what will be the discount rate. Okay, and we don't want to look on the WACC. We want to look on some other discount rate. Okay, so this is the first thing. And the second thing, which is very notorious, and I gave you the example of Westinghouse, okay, is a problem if you underestimate or you overestimate your cash flows, your price will be off, okay? So how to mitigate it, how to cope with that, that's a topic for another video, okay? So I hope that this video, even though it's messy, it's like a battlefield, actually helps you to, segregate and kind of decide and understand the differences between the internal rate of return, the modified internal rate of return, and the NPV. All right? So hopefully you will have a great summer, and some of you I will see probably next year. Thank you and have a great day. Bye.